Dear friends, we can move to the last topic of the chapter, motion. Our last topic is uniform circular motion. All of you are familiar with the term uniform motion. And here the only difference is we are considering about the uniform circular motion. See, we have studied that when the velocity of an object changes, we can say that the object is accelerating. The change in velocity can be occurred due to the change in direction of motion or change in the magnitude of the speed or velocity. And can you think of an example when magnitude of the speed is not changing but the direction of motion changes? Here, a sportsman is traveling, the sportsman is running through a rectangular path. He is moving with a constant speed, he is not changing his magnitude of speed, but he has to change the direction. So what we can say that in this case, he started from A and it moved with the velocity 5 meter per second. He is traveling with the speed of 5 meter per second. That means he can cover 5 meter in 1 second. It's just an example. So he started from A and reaches B with a constant speed. But here he is not changing his speed. Suddenly he turned to this side. Then again he moved with the same speed. Each and every point he is not changing his speed. Here when he reaches B, again he changed the direction. Here we can say that the velocity is changed. Why? Because change in velocity can be occurred due to the change in direction of motion or change in magnitude. In this case, the magnitude of the motion is not changing. The magnitude of the velocity is not changing, but the direction changes. How many times he changes direction? He started from his starting point A. When he reaches B, he changed one time. Again at C, again one time, then D. Totally 3 times he changed the direction. So this is an example for the case when the velocity change even without the change in magnitude of motion, magnitude of speed. Here the change in velocity is due to the change in direction, not because of the magnitude. This is one example. Similarly here you can see the hexagonal track. So how many times he will change the direction? How many times the velocity will change in this figure? He started from A, B one time, C second time, third time, fourth time. How many edges are there? 6 edges are there. So the velocity will change 6 times. The reason is he is changing, even the body is moving with a constant speed, but the directions are changing. So in the hexagonal, this is octagonal, he is also changing the velocity. Finally, he is moving the circle. So how many times he changes his velocity? It's not possible for us to count the number of times change the velocity. The reason is in circular motion, at each and every point the direction is changing. For example, if the object is at here, what will the direction of motion? This, just to a tangent. This will be the direction. If the object is at here, then again here will be the direction. Here also at each, can you count the number of points? Here, no, it's not possible. So, suppose if there are 100 points, 100 times the velocity will change. Then, now we can move to the definition of uniform circular motion. When an object moves in a circular path with a constant speed or uniform speed, then it is said to be uniform circular motion. I will repeat. When an object moves in a circular path with a constant speed, then the object is said to be uniform circular path. Uniform circular motion. Here, the equation to find the velocity of an object when it travels in a uniform circular motion is given by the equation E equal to 2r divided by t. See, r is the radius of the circle through which the object moves. Let r be the radius of the circle, then what will be the diameter? 2r. So, velocity will be equal to 2r divided by t. We are going to by this equation. Okay. So, what we have studied in this section, we have defined the uniform circular motion. When an object moves in a circular path with a constant speed or velocity, then the object is said to be in uniform circular motion. And there is one equation to find the velocity. The normal equation of velocity is displacement by time. Here, the equation is velocity v equal to 2r divided by t. R means the radius of the circular path. And one example is given. You are just tying one stone with a rope, a thread. Just rotate that stone. Suppose it will you are rotating that stone with a constant speed, then you can say that the stone is moving in uniform circular motion. Is it clear? So you are standing at the center and just tie a stone and rotate that. Then you can say you are rotating the stone with the same speed, then you can say the stone is in uniform circular motion. Suppose you are rotating the stone. If you want to find the direction of velocity at this point, what you have to do? You have to, when the stone reaches this point, just untie the stone. Then it will move to this direction, isn't it? Then that will be the direction of velocity. Similarly, at each and every point, the velocity will change. In uniform circular motion, at each and every point, the velocity will change. That velocity can be found by drawing a tangent to that point. If you want to find the velocity of that body at this point, you have to draw the tangent. You have to draw the tangent to that point. If you want to find the velocity of the direction of velocity of the object at this point, you have to draw the tangent. In maths, we will study how to draw the tangent lines. Okay, now we have finished the chapter.